All right, Matt 2, here we go. We've got just a little extra lesson, how to simplify the answers that we're getting from the quadratic formula. Okay, so first thing I've got here is a problem that kind of looks like the quadratic formula after we've plugged in some stuff, where we did like the b squared minus 4ac stuff. So here we go. Okay, so when the radical simplifies to a whole number, we're going to give two answers to it. So in this problem, 25 minus 16 is 9. So we get negative 5 plus or minus the square root of 9 over 8. And then the radical root 9 is going to become 3. So this is a situation where the radical has simplified to a whole number. So it's rational now instead of being irrational as a radical. When this happens, we don't leave our answer looking like this. What we do is we split it up into two answers. We're going to do negative 5 plus 3. Negative 5 plus 3 is negative 2. And then we put it over 8. Our other answer is going to be negative 5 minus 3. Negative 8. Also over 8. And then those reduce to become negative 1/4 and negative 1. So when our radicals reduce, we are going to split it up into the two rational answers. Next one. What if our radical ends up being negative like this problem here? So on this one, when I've got my answer, 25 minus 28, I get negative 3 over 2. So I've got an imaginary answer here because we have the square root of negative 3. So we're going to, remember, negative, we're going to change that to an I. So we're going to leave our answer as 5 plus or minus I root 3 over 2. Okay, so we're not going to say no real solution. There's no real solution, but we now know that we can give the imaginary solutions. So that negative in the square root is going to become I. The I goes in front. Do not put it behind, please. Put it in front. All right, here's a problem. I've already combined these two things right here. I've got root 18. Now, root 18 is not a perfect square, but the radical can reduce, meaning I can split this up into 2 times 9, and then 9 is 3 times 3. So I've got a pair of 3's and a 2 left over. So when that radical does reduce, we're going to reduce it. So we would get 2 plus or minus 3 root 2 over 2. So we're going to reduce our radicals if they can be reduced. Simplify our radicals is really what I mean. All right, if after reducing what's that supposed to be? Oh, the 3 whole numbers can reduce, then we're going to reduce them. All right, so I'm going to reduce this one real quick. This is 4 times 6. 4 is 2 times 2. 6 is 2 times 3. So 24, I have a pair of 2's and a 2 and a 3 left over. So I've got a 6 plus or minus 2 root 6, because 2 times 3, the 6 goes in there, over 8. So what this is saying is when the 3 whole numbers can reduce, so 6, 2, and 8, all of those can reduce, only when all 3 can reduce. In that previous problem, 2 of them reduced, but all 3 did not, so we didn't do anything else. But when all 3 can reduce, we're going to reduce them. 2 goes into all 3 of those numbers. So this becomes 3, this becomes 1, this becomes 4. Our final answer is going to be 3 plus or minus root 6. We can put the 1 in front if you feel like it, over 4. You don't have to put that 1 there. Okay, so that's how you would reduce that one. All right, last one, reducing with imaginary numbers. So here I've got negative 45. So I've got negative 1 in there. Remember, that becomes I. But 45 reduces to 9, or multiplies 9 to 5. And then we got a pair of 3's. So I got a pair of 3's and a 5 left over. So I've got plus or minus. 3's go out. The negative becomes I. And then I got a 5 left over. All over 6. But remember, our last one said if the 3 whole numbers can reduce, then we reduce them. So here, the 15, the 3, and the 6 can all reduce. 3 goes into all of them. 3 goes into 15 5 times, 3 goes into 3 once, and 3 goes into 6 twice. So my final answer for this one is going to be 5 plus or minus 1i, or we can just write I, root 5 over 2. All right, let's practice some of them. All right, here I got a whole bunch of problems. So what you can do is pause the video if you're following along, and this is the first time you've done it. Try to work some of these out. Go ahead and pause it right now, and then I'll come back and show you the answers. All right, you pause? All right, so I'm going to work them out now. Hopefully you've already paused if you wanted to work them out yourself. So this one, root 25 becomes 5, so I got negative 10 plus or minus 5 over 2. Since everything is rational at this point, I give my two answers. This becomes negative 5, or negative 10 plus 5, which is negative 5 over 2. And then negative 10 minus 5 is negative 15 over 2. So those are our two x-intercepts. The two x-intercepts are negative 5 over 2, or negative 2.5, and negative 15 over 2, or negative 7.5. Next one, same thing. This one is a perfect square. So we get 4 plus or minus 4, square root of 16 is 4, over 8. So since everything's rational here, I'm going to give my two answers. 4 plus 4 is 8 over 8, and 4 minus 4 is 0 over 8. So my two answers are 1 and 0. So the two x-intercepts would be at 1 and 0 for that one. All right, next one. 6 is not a perfect square. It also doesn't reduce. It's just 3 times 2. There's no pairs in there, but I've got a negative in there. So I'm going to change that negative into I. And I get I root 6 over 4. Now the 4 cannot reduce with the radical. Only whole radicals reduce with radicals. So this is as far as I can go. Next one, 72 does reduce. That would be 9 times 8. And then 9 is 3 times 3. And 8 is 2 times 4, and 4 is 2 times 2. So I got a pair of 3s, I've got a pair of 2s, with a 2 left over. Also, this one's negative here. So this would be negative 9 plus or minus 3 and 2 come out. So that's going to be 6, because everything's a factor, everything's multiplied. It's negative, so I need an I, and then 2 stays in, all over 6. Now on this one, all of these numbers over here can be reduced. So 3 goes into all of them, so this would become 2, this would become 2, this would become 3. So my final answer, after I reduced it, is negative 3 plus or minus 2i root 2 all over 2. Next one, 32 is 16 times 2, so I can reduce that. And 16 is 4 times 4. So I got a pair of 4s and a 2 left over. So this would be 3 plus or minus 4 root 2 over 4. Now these 4s can reduce, but this 3 and this 4 doesn't reduce. So since all three of those numbers don't reduce, I'm just leaving it like that. Next. So over here, root negative 16 becomes plus or minus 4i over 2. Okay, so on this one, 2 can't reduce with the 21, and it can't reduce with the 4. Now, since there's an I in here, we're not going to split it up into the two answers. We're just going to leave it like that as 21 plus or minus 4i over 2. So the I is kind of representing a radical, so we're not splitting it up into our two actual answers there. I mean, we could. This would be 21 plus 4i over 2 and 21 minus 4i over 2, but we're going to just leave it like that. Next one, 27. This is 3 times 9. 9 is 3 times 3, so I got a pair of 3s with the 3 left over. So this is negative 12 plus or minus. The 3 comes out. It's negative, so I add I, and then there's a 3 left over, root 3, all over 6. Now since all three of these can reduce by 3, I'm going to do that. 3 goes in there 4 times, goes in here once, goes in here twice. Final answer. It's going to be negative 4 plus or minus I root 3 all over 2. Next, 50. That splits up. That's 25 times 2. And 25 is 5 times 5. So I got a pair of 5s, 2 left over. So I'm going to get 8 plus or minus 5 root 2 over 4, because I had a pair of 5s, 2 left over. 8 and 4 reduce, but 5 and 4 don't reduce. So I would just leave it like that. All three numbers have to reduce. Next one, 84. 84 is 2 times 42, and 42 is 2 times 21, and 21 is 3 times 7. So I've got a pair of 2s and a 3 and a 7 left over. So I'm going to get negative 15 plus or minus. The 2 goes out. The 3 and the 7 stay inside. So that's 3 times 7, 21, over 10. Now the 2 and the 10 reduce by 2. The 15 and the 10 reduce by 5. But all three of them don't reduce by the same amount. So we would just leave it as negative 15 plus or minus 2 root 21 over 10. Next. All right, on this one, this is a perfect square. That's a perfect square of 6, but there's a negative. So this is going to be negative 6 plus or minus 6i all over 2. Now, since all three of these numbers can be reduced by 2, I'm going to go ahead and reduce them by 2. So these 6's become 3's, and this becomes a 1. So our final answer is negative 3 plus or minus 3i. The 2 is just a 1. You don't need to put it over 1. So that's our final answer. All right, almost there. This is 4 times 2. And 4 is 2 times 2. So I got a pair of 2's with the 2 left over. So I get negative 2 plus or minus 2 root 2 all over 2. And all three of these 2's reduce and become 1's. So our final answer is negative 1 plus or minus 1 root 2, or we can just write root 2. We don't have to put it when it's over 1, so that's our final answer, negative 1 plus or minus root 2. Whew. All right, almost there. Next, we got 14 plus or minus root 28 over 2. 28 is 4 times 7, and 4 is 2 times 2. So I got a pair of 2's, 7 left over. So this would be 14 plus or minus 2 root 7, because the pairs go out, single stays in, over 2. All three of these do reduce by 2. So I'm going to make this into 7, this into 1, this into 1. Final answer is going to be 7 plus or minus root 7. Done. All right, so that's how you reduce your quadratic formula answers. Math hard. See you guys later. Bye-bye.